Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at using tree diagrams to solve probability questions that are with replacement. So this is the kind of question for which we would use such a diagram. So let's say Mr. Luck has a bag of chocolates, 7 Mars bars, 3 boosts. If I pick 3 chocolates from the bag, one after the other at random, what's the probability at least 2 of them are Mars bars? So let's look at this first from the point of view of independent events like we have been looking at. Well, you probably realize the probability I get at least 2 is the probability that I get 2 Mars bars plus the probability I get 3 Mars bars. Obviously can't get any more than 3 Mars bars if I'm only picking 3. So we can figure this one out pretty simply. This one's a little harder. So to figure this one out here, we need a bit more information. So let's say I want to find the probability that I get 3 Mars bars in a row. Well, we know the probability that the first Mars bar picked is 7 over 10. But we need to be told whether this question is with or without replacement. In other words, after I take the first Mars bar, is it replaced by another Mars bar, or do I not replace it at all? Of course, that would affect the probability. So in this video, we're going to go through with replacement and we'll go through without replacement in a subsequent video. So if it's with replacement, after I pick the first Mars bar, I replace it with another Mars bar. So the probability I get a Mars bar second go is still 7 over 10. Probability I get 1/3 go is still 7 over 10. That's the easy part. Now this part here is a little more complicated. So the reason this is more complicated is there's more than one way this can happen. So if you're thinking about getting 3 Mars bars in a row, there's only one way that can happen. You have to get a Mars bar, Mars bar, Mars bar in that order. If you want to get just 2 Mars bars, well, there's a couple of ways that could happen. You could get a Mars bar first go, then a boost, then a Mars bar. You could have 2 Mars bars, then a boost, or a boost, then 2 Mars bars. There's actually 3 ways that I could pick 2 Mars bars and a boost. So I'd have to find the probability of each of these and then add them up. So you could do it that way. There's no problem with it. It's just that people usually find it a bit tricky to realize that. So instead, if we draw a tree diagram, it will tell us all of the possible outcomes. So this is how we draw the tree diagram. So we have a column for each stage. So here there are sort of 3 stages. Each stage is picking a different chocolate. So all you do is write the outcomes. So first go, I could get Mars bar or boost. Second go, well, I could get Mars bar or boost again. And similarly, on the third go, I could get Mars bar or boost. So that's what the tree diagram looks like. And then what I'm going to do is I'm going to write the outcome. So here, the number of outcomes is 2 times 2 times 2, which is 8. So to find each outcome, I just follow the branches. So first outcome is M, M, M. Next outcome would be M, M, B, and so on. So here we have our 8 outcomes. It might be tempting for you to think, oh, cool, each of these has probability of occurring of 1/8. That's not true because they're not equally likely to occur. What I have to do is write the probabilities on the branches. So the probability of getting a Mars bar first go is 7 over 10 and boost is 3 over 10. Now, because this is with replacement, if I get a Mars bar the first go, probability of getting a Mars bar second go is still 7 over 10. And then boost is still 3 over 10. So everywhere you see an M, it's 7 over 10, and boost is 3 over 10. So to find the probability of each of these 8 outcomes, we multiply the branches. So for M, it's 7 over 10 times 7 over 10 times 7 over 10. Exactly what I had up here. And so I get 343 over 1,000, or 0.343. So that's the probability of getting 3 Mars bars in a row. So what's the probability of each of these? Well, for MMB, that's this one here, MMB would be 7 over 10 times 7 over 10 times 3 over 10. And if I put that in my calculator, I should get 147 over 1,000. Now, what about the probability of getting MBM? Well, I can just follow that again. MBM, 7 over 10 times 3 over 10 times 7 over 10. That actually gives me the same answer. So what we should notice here is that all three of these give you the exact same answer. These three are actually equally likely to occur. So the probability that I get 2 Mars bars and 1 boost is just these three added together. And that will give me 441 over 1,000. So the probability I get at least 2 Mars bars, I just add these two together and I get 784 over 1,000, or if you like, 0.784. And that's my final answer. So yes, if you wanted to go this way and just do what we did using independent events, that's fine. It's just that tree diagrams are a good way to display all of the possible outcomes, because sometimes it's easy to forget one or more of these outcomes. All right, thank you so much for tuning in to this video. This has been the luckiest maths teacher in the world. Have a great day.